Bismillahirrahmanirrahim, guys. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Atiq is here once again from the science department. We have week 14, physics, chapter 14. The pages we are going to cover for this section ranges from 500 to 505. Section 3, optical phenomena. Now look at, we have a preview regarding this session. The objectives, then the total internal reflection, atmospheric reflection, remember, dispersion and lens aberrations. Objectives, prediction, recognition, how we recognize the things and then explain it. In the predict, we will assume something, we will create some idea, we will just do our own stuff, statements, ideas. Whether the light will be refracted or undergo total internal reflection will occur. That is what we can predict only, like two things. Then recognize, we will study it, that in atmospheric conditions that causes refractions, we will know. And we will explain that dispersion and phenomena such as rainbows in terms of the relationship between the index of refraction and the wavelength. So different kinds of paths from the refractions will occur in this phenomena. This is the optical thing. Understand optical, like through eyes, what we can see, what we can observe. So we will study it there. Total internal reflection. What are total internal reflections? It can occur when light moves along a path from a medium with a higher index. Let me bold it for you guys. Of refraction to one with a lower index. Which one? A lower one. So it is a relationship from the higher index to the lower index. The indexes of refraction then, okay. At a critical angle, a refracted light makes an angle of 90 with the normal one, of course, because the refraction will occur there. So this is what reflection. So the reflection usually reflect how to bounce back the things with a 90 angle usually. It is a standard. Above the critical angle, total internal reflections occur and light is completely reflected with a substance. Of course, when it strikes on something, it will reflect back at the 90 angle. Okay? Look at, for example, total internal reflection with a graph. This is a physical structure. Look at, the ray is coming out like from here, you can say. So it's striking to a thing. This is the incident angle. So look at 90 angle it will make again to go upward. Understand, this is total internal reflection. As we are studying the optics, look at, this is the optical one, okay, our eye. Atmospheric reflection now. How the atmosphere can affect. A reflected light can create a mirage, okay. Look at, a mirage is produced by the bending of light rays, rays in the atmosphere where there are large temperature differences between the ground and the air. Dispersions. Look at, come to graph this one. Look at, this is a ray which is coming from a source, like this is what the atmospheric thing, to the eye, and eye is going to reflect it back. Look at, from which angle? Just the opposite side one. Look at dispersion now. Dispersion is the process by separating polychromatic light into its component wavelength. White light passed through a prism produces a visible spectrum through the dispersions. White light, look at, passing through, this is a prism. In front of the prism, look at, the white rays or light is passing through. So the red and the blue, they are just making different angle thetas here, okay. This is known as what? Dispersion, okay. Now look at again the optical thing is just covering here. Rainbows, different colors, usually in the Asia we observe a lot of rainbows colors there, okay. The rainbow has a phenomena whenever the earth equator is just quite near to the sun. So the sun will be there, like at the daytime, you can say after Asr we usually saw the rainbows, okay, from the east. Look at sunlight they are coming. That's why if a man saw from downward, the sunlight rays will reflect towards them, so he can see through it through the eyes. Understand? Lens aberrations. Lens aberrations. Chromatic aberrations. It is the focusing of different colors of light at different distances behind a lens. Chromatic aberrations occur when the index of refraction varies from different wavelengths of light. Look at different, like multiple lights, they are coming. Okay, it is passing through a lens. Look at, some of them will strike, we call them like violet one, then the red, they will just strike at a point as well, the red one. Look at, and the straight one as well. So they have different wavelengths there. Okay, but behind the lens, remember, we call them what? Lens aberrations. Okay, fault you can say as well here. So it was today's lecture. Kindly, this is a simple optical phenomena. You need to study it hard, and I will upload some sheets for you guys in the upcoming week. Kindly do follow it, and this is so much compulsory for you guys, okay, to solve that sheets. Thank you so much. Fi aman Allah.